Hey, hi everyone. So for this video, I will discuss the different sample problems in algebra. So we have two parts in algebra. So the first part will cover the following, although not every aspect of each of the topic can be discussed. So just a brief overview or a brief example of some of these topics will be discussed. Okay, so without further ado, I will just start the first problem. So for the first problem, we have uh, the following choices, and you want to choose which of these four has four significant figures. So regarding the significant figures, it is how many how many significant figures it has. So for letter A, it has two significant figures. So two. And for letter B, we have one, two, three, and four. So we have four here. And then we have three. And this one is actually five. So how do we count significant figures? No? So we start from the first place and then move on to the right until it reaches some number. No? So meaning this will be the answer. So letter B. Okay, so solve for k. We have 3 times 9 raised to k is equal to 3 is equal to 5 raised to k. Sorry, 3 raised to 5 times k. So, how do we solve for this? Actually, you can use your calculators directly. But to solve this analytically, we have to change this 9 into the same base as this 3. Okay? So, 9 is equal to 3 squared. And then this one is actually, we have a property of exponents wherein we can multiply this 2. So, we have 3 raised to 5k. Okay, and then we can simplify this one. So we have 3 raised to 4k. So 2 times 2k is 4k. And then this one. So we have a property in exponential multiplication, no? A multiplication of two polynomials that if you multiply this 2, when it has the same base, then we can rewrite this one as 3 raised to 1 plus 4k. And then equals to 3 raised to 5k. So therefore, we have an equation that uh, we can equate this 1 plus 4k and 5k. So we have 1 plus 4k is equal to 5k. So as you can see, now we can transpose this 4k. So we have 1 is equal to 5k minus 4k. Therefore, this is k is equal to 1. So 1 is the answer. So what is the solution of the following system of simultaneous linear equations? So how do we solve for this? There are different ways or a variety of ways to solve for simultaneous equations. And one way to solve this is to utilize your calculators. So using your calculators, there is a function here that we can explore. So we have mode 5, so mode 6. No, mode 5, no? Equation, and then we can choose the second one. So the second one has three equations, three unknowns, ano? And then we can entry the respective values here. So we have 10, 3, 10, 5, and then 8, -2, 9, 3, and then 8, 1, -10, and 7. Okay, so just a disclaimer, you have to make sure that the variables are in order and the constant is on the right side of the equation. No? So equate this, so we have an answer here. So x is equal to, we have a vector here, so 0.6253. And then we have 0.1861. And then equals negative 0.1811. Yeah. Okay, so basically this is your x1, this is your x2, and this is your x3. Wherein we have here x, y, and z. So we can write this as x, y, and z. Okay, so moving on, we have another problem here. So find z when z is equal to square root of 1 minus square root of 1 minus square root of 1 and so on. Okay, so to solve this, since this is a nesting function no, or nested function, no? So we can rewrite this one as z is equal to 1 minus c. So as you can see, no, this portion is the same as this one, no? So we can rewrite this portion into z. That is why we can rewrite this as z, no? And then simplify the equation, so square this both sides. So we have z squared is equal to 1 minus z. And then transpose the z. And then equals to, or sorry, minus 1 and then equals to 0. Okay? So to solve for this quadratic equation, we have a variety of ways to using your calculators, but we can utilize the mode 5 and 3 using this four quadratic equation. So in here, we will just input the coefficients of our quadratic equation. So a here is 1, the coefficient of z squared, b is 1, and then c is -1. So the solution here, we have 0.618 and negative. So the answer is 0.618 z is equal to 6 this one, no? So z is also equal to negative 1.618, although the solution here, since this is a square root, no, this will not be true for the realm of real numbers. So this should be the answer. Okay. So given A and B, or matrix A and matrix B, find the determinant of matrix A and matrix B. Okay, and so on. So there's a lot of things that we should do here. So there are different ways to solve for this. No? So I'll just write down how do we do this in your calculator. So for the determinant, we can just utilize the matrix function, and we can just input here determinant of matrix A. Assuming that we already input this matrix A and matrix B, no? So matrix A, we will input this later. And then for this one, we have matrix B. And then for the difference, we just have the difference, assuming that A is positive here, so mat A minus mat B, okay? And then for the product, so assuming that A is the left side, so we have mat A times mat B, that is the direct. And then for the inverse, we have inverse of mat A. For the transpose, we have function TRN, transpose mat A. For cofactor, so how do we solve for the cofactor? No? So we actually have a definition for the inverse of a matrix, if you can remember in your linear algebra. So A inverse is equal to 1 over the determinant of A times the adjoint of A, wherein the adjoint of A is the transpose of the cofactor matrix. So we can utilize this definition to solve for the cofactor. So for the cofactor, we can see that A inverse is equal to 1 over the determinant of A times, so since this is the transpose, we can say that also properties of matrices, we can also transpose this C. So we have here CP, no? And then to solve for C here, this will be equal to, so we have A inverse times the determinant of A, and then the transpose of this, ano? Ayan. Okay? Since if you simplify this, it will be the form. So the function that we should utilize here in your calculator is transpose of the inverse of A multiplied by the determinant of A. Yan. Okay? And then the classical adjoint of matrix A. So the classical adjoint basically means that is just the adjoint, no? Adjugate or adjoint of A. So we can just solve this one, and we will have here a direct solution of inverse of A times the determinant of matrix A. So this should be matrix A pala, no? Matrix A. Yeah. Okay, so we don't need to input the dot, no? So I'm just implying that we are multiplying this too. So let's input this in our calculator. So we have mode and then matrix, so 6 and then 1. So we have 1, 6, 0, 4, 2, 7, 0, 5, and then 3. And then for the other matrix, so this is for matrix A, so shift matrix, so shift 4. And then we can just input the data for matrix B. So we have here 1, -2, -4, -3, 6, -7, and then 4, -4, and -6. So let's say we want to find the determinant of matrix A and matrix B. So there should be two formulas here pala, no? So also the determinant of matrix B. Okay, this will be just now, so AC and then shift matrix. So find the determinant, so 7, and then input matrix A, so shift matrix. And then we can choose, let's say, matrix A, so 3. So input this, you will find the determinant of matrix A is -101. For matrix B, just do the same thing, but change this matrix A into matrix B. Okay, we have 7 to 6 as our determinant. And then to find the difference, let's say you want to find the difference between these two matrix. Assuming that A is the positive, no? We have matrix A minus matrix B. That will be this matrix, okay? So this will save you a lot of time when computing matrices. And then for the product of two matrices, we have shift matrix 3, shift matrix, and 4. So we have here the matrix multiplication or well, yes, matrix multiplication lang naman talaga to, no? Okay. And then for the inverse matrix, so don't get this wrong, no? Sometimes you'll get this wrong. So don't use this, no? Don't use this one. You should use the shift and then the inverse here. Sorry, not the shift, no? But this inverse here, no? So x inverse to find the inverse of this matrix. We have here, we have a rational representation and also this numerical answer, ano? Okay, so for the transpose, again, we have shift 4 and then 8 transpose. So we use the matrix A again. Ayan. Okay. So this is the transpose of matrix A. As you can see, we have 1, 6, 0, 4, 2, 7, and then 0 and 5 and 3. For the two-factor matrix, this is a lot of things, no? We have to input a lot of things here. So transpose and then inverse of matrix A, inverse of matrix A, and then the determinant. So shift matrix determinant of matrix A. Sorry, I input here matrix A, you know, but it should be not A. No? Okay, and then equals. So this will be the cofactor matrix of this matrix A. And then for the classical adjoint, so we have shift, basic muna, no? Shift matrix, and then we have matrix or inverse. I think we can utilize this previous one. We just have to delete this transpose, ano? So I always delete this transpose. So the adjoint matrix is this one. Okay, so it is that simple. So just remember this method, and you can always solve matrices, but this will be only limited to 3 by 3 and 2 by 2 matrices, no? For square matrices. For 4 by 4, I don't have a shortcut there, but there is a way to solve for this, no? Using your calculator, but we don't have much time to discuss this, no? But it will come, no? When you're reviewing for your board exam. Okay, so what is a polar form of the complex number c is equal to 3 plus 4i? Okay, so this is easily calculated in your calculator, but you have to be careful with using your calculators, no? Sometimes it can be troublesome when we become too dependent using our calculator. So one of the things that you should remember when dealing with complex numbers is that we have four quadrants, no, in the Argand diagram. So this is the I axis, and this is the real number axis. Okay, I'll just put I here. So if we have a point here, then this will be your theta, and then this will be your r, right? And then if we have another point here, then this will be our angle, no? So this will be our new angle, and then this will be your radius, and then so on. So for the third quadrant, we have an angle coming down from below as theta. This will be our r, and then this one, we have an angle here again, theta. This will be your r. So take note that we can form a triangle here. And as you can see, the sign here is positive for this horizontal portion of the triangle, and this will also be positive. But for this second quadrant, the horizontal will be negative, no? And this will be positive, the opposite side. And then for the quadrant 3, this will be negative for the height, no, of this triangle. And this will also be negative with respect to its horizontal. For the quadrant 4, we have a negative uh, vertical height, and then positive horizontal portion of the triangle. So always take note of that, no? So meaning for quadrant A, you have positive real part, positive imaginary part, positive negative real part, positive imaginary part, and so on. Okay, but how do you solve this? So we have here z is equal to 3 plus 4i. So let's just utilize our calculator to solve for this. Okay, remember this. Okay, so we have mode 2 for complex. So 3 plus 4i. Okay, and then we can use shift 2, and then we can we can convert this into its polar form, which is 3. So the polar form of this complex number will be 5 and 0.9273 in radians now. But if you want this in degrees, we just change the angle into degrees. So we have 5 and 53.13. So the answer should be 5 and 53.13 degrees. Okay, so what is the cube root of the complex number? So in here, how do we solve for this? So a definition of the complex number, or the complex roots of the complex number, is z raised to 1 over n is equal to r raised to 1 over n angle, no? Angle, we have theta over n. So that's straightforward, no? So the r here, no, is 8, and the theta here is 60. So therefore we have 8 raised to 1/3, and then the angle should be we have 60 over 3. So the answer here will be 2 angle 20 degrees. Okay. So refer to the vectors A and B. Find the resultant vectors of A and B. Length of vector A, the dot product of A and B, the cross product of A and B. Okay, so we can also utilize some calculators for this one. So when we're talking about resultant vectors, it could be actually just the vector itself, but we can also find the length of this resultant. No? It depends on the context. So for number or letter A, okay, let's input the vectors first. So we have vector A, so the dimension is 3, since we have 3 directions. So input vector A, so 2, 4, and 8. Okay, and then for vector B, so I'll just input data, and then 2 for B, and then 1. So we have -2, 1, and -4. So AC, and then shift matrix, and then we have to find the resultant. So how do we find the resultant? When we're talking about the resultant, we're finding the sum of the vectors. So we want to add vector A, and vector B. Sorry, actually vector and then 4. So the sum of this vector is, so A plus B vector will be equal to 0i plus 5j plus 4k, or in other words, this is 5j plus 4k. Okay? If you want to also find the length, no, of this vector, we can also find the absolute value. No? So there goes the absolute value here. So to find the absolute value, or sorry, the length of the vector, we can find the absolute value of our vector. So for, let's say, we want to find the length of vector A. So we have shift vector 3, and then absolute value. So we have shift abs, and then enclose this vector. So the length of vector A is 9.1652 units. Okay. For the dot product, how do we find the dot product of two vectors? We can utilize an operator here. So shift 5, and then we have dot, no? So 7. And then input also the vector B. So 4. So the dot product will be negative 30. Okay. For the cross product, you just have to remove this dot. So the cross product is basically just the multiplication of the two vectors. So the answer should be, we have here negative 24i minus 8j plus 10k. Yeah. Okay. And then what is the angle between the two given vectors A and B? Okay. So how do we find the angle between two vectors? So we have cosine theta is equal to the dot product of A and B over the length of A times the length of B. So basically in your calculators, okay, I will simplify this first. So utilizing your calculators, you can solve this pretty quickly, you know. So we have shift cosine, and then directly we have vector A, and then dot vector B, and then all over the absolute value of vector A, and then multiplied by the absolute value of vector B. Yeah. So the answer here should be, oh sorry, what is that? No? So chef, I think this is the same given. Oh, it's not the same given, no? So we have to input again our new vectors, no? So shift vector, and then dim, ano, and then 1. Okay, so you'll change this as 4, 12, and 6. Okay, and then for the other vector, sorry, shift, we have vector B, so 24, negative 8, and 6. Okay, so AC and then shift vector. Sorry, I think we have to input first the inverse cosine. So shift cosine, and then I guess we can use the parentheses first. So vector A, so shift vector 3, and then dot. So dot vector B, and then divide this by the absolute value of vector A. So absolute value, where's the absolute value? Okay, shift vector 3, and then times shift absolute value. Sorry, absolute value pala muna, ano? So shift absolute, and then vector 4, and then close. So that will be your answer. So the angle here will be 84.32 degrees. So theta will be equal to 84.3241 degrees. So that will be your answer. Okay, so what is the sum of the following finite sequence of terms? How do we solve this? Okay, so as we can observe now by inspection, we can just try dividing this or adding, no? If to see if this is an arithmetic sequence or a geometric sequence. So I think this will be a geometric sequence. Since when we divide 80 by 32, it should have a same ratio when we divide this by 280. Okay, so this is a geometric sequence since we are multiplying 5 halves, no? So the ratio here that is jumping from this number to this other number is multiply this by 5 halves. So we can already say that the ratio is 5 halves. And how do we solve for the sum? So for the sum of a finite sequence of terms in a geometric series, this is equal to actually we have a 1 minus r raised to n over 1 minus r, right? Is that right? Okay, that is correct. No? And since we do not have a given n, no, we don't have a given number of terms, we have an alternative formula wherein if we simplify this, okay, since we know that the last term actually, no, we have another formula, we have the last term as a times r raised to n minus 1. As we can see now, if we add here, if we add -1 and +1, then this will be equal to a minus a times r raised to n minus 1 times r. Ano? So this portion is L. So we can rewrite this as, so S is equal to a minus RL over 1 minus R. So we have a given for the A. So A is the first term, L is the last term, and the R is also given, which is 5 halves. So we can solve this directly. So we have 32 minus 5 halves times L, we have 19531.25, and then all over 1 minus 5 halves. So okay, let's solve this one. So 32, okay, sorry, mode 1 first, no? So 32 minus 5 over 2 multiplied by 19531.25, 1 minus 5 halves. Okay, so the answer is 3 to 5, 30, 3 to 5, 30.75. Okay? So review the geometric and the arithmetic series to remember what formula should we use. Ano? Okay, so a rubber ball was dropped from a height of 36 meters, and each time it struck the ground, it rebounded to a height of 2/3 of the distance from which it fell. Find the total distance traveled uh, by the ball before it comes to rest. So how do we do this? No? So we can do this by utilizing actually the geometric series. No? So as you can see, no, initially it has a 36-meter height, and after one rebound, it will become 2/3 of the 36 meters. No? So this will become 24. And then after that, it will become 2/3 of that. So this will be about, well, I won't compute this anymore. No? So as you can see, this will be a continuous multiplication of the ratio of 2/3. Okay? So we want to find the total distance. So we are trying to find the sum of this series. Although be careful, no? This is a little bit of a trick, no? So the first fall of the ball, that will be 36 meters. But after that, since it will rebound upwards and then downwards, so this will be 24, and then this will be 24, and then it will rebound again. So we should multiply this by 2. Ano? This sequence should be multiplied by 2 for this portion, and then we should add 36. So the total distance that we're trying to find is the infinite sequence of solution. So we know that the sum is equal to we have a over 1 minus r, right? When r is less than 1, okay, or greater than 0, we can solve for this. So how do we solve for this? So we have 36 times the s, no? So we have a here is equal to 24. So we have sorry, not times but plus we have 24 over 1 minus 2/3. And then you should multiply this by 2. Since the rebound, we have to account for the rebound, so it will be times 2. Okay? So that the total distance will be equal to uh, so 2 times 24 over 1 minus 2. So we have 180 meters as our final answer. Okay? And then we have this problem. So twice the sum of the two numbers is 22. The numbers of the squares, so the sum of the squares of the two numbers is 61. The product of the two numbers is what? Okay, so we have twice the sum of the two numbers. So let's say x and y are the two numbers. Okay, so we can actually simplify this into, so we can divide this by 2 for both sides. So this will become x plus y is equal to 11, right? To simplify this equation. And then for the second sentence, we have the sum of the squares. So the sum of the squares of these two numbers is equal to 61. So what we're trying to find for is the product of the two numbers. So we are trying to find for xy. So how do we find for xy here? Okay, so there are different ways. No? There are countless ways to do this. But the easiest one, the easiest method for this specific scenario is that we can actually square this. No? So upon squaring this, we have x squared plus 2xy plus y squared is equal to 11 squared, right? And as you can see, no, if we square this, the reason for squaring this is that we will have this term. So we can see that x squared plus y squared will be equal to 61. So we can see that 2xy plus 61 is equal to 11 squared. And to find for xy directly, we know that this is what we're trying to find, the product of these two numbers. So we can solve this xy by transposing this and dividing by 2. No? So we have xy is equal to 11 squared minus 61 over 2. So therefore, the product of these two numbers, a will be 11 squared minus 61 over 2. So we have 30. No? So this will be 30, our product. No? So xy is equal to 30. Ayan. And then, after that, I think this will be the last. Okay, so we have a work problem. So Tukmol can paint a fence 50% faster than Nico and 20% faster than Titusho, and together they can paint a given fence in 4 hours. How long will it take Tukmol to paint the same fence if he had to take the work or he had to work alone? Okay, so how do we do this? Yeah. So for work problems, we have 1 over A plus 1 over B and so on is equal to 1 over the total hours, no, to finish. So what is A? What does A and B and T mean? So these are the time, no? The time it takes for the job to finish. So this should be the total time. This will be the independent time for each of the persons to finish this job, no? So for Tukmol, we have 1 over T U. Okay? So Kikoy can paint Tukmol can paint 50% faster than Kikoy. So alternatively, Kikoy will be 50% slower, no? So Kikoy will take 1.5 more time to finish, diba? And then for Tiburcio, we have 20%, no? So Tukmol can paint 20% faster than Tiburcio. Therefore, we can say that in some way it will take 1.2 times the time for Tiburcio to finish. No? So we have 1.2. Sorry, this should be Tukmol, no? So this will be 1.2 times the time it will take for Tukmol to finish. So equals to 1 over the total time. So it says that they can finish it together in 4 hours. So this will be your total time. And we can just solve this using our calculators. So therefore, TU will be equal to, so we have 1 over x, no? Plus we have 1 over 1.2x. And then plus we have 1 over 1.5x. And then equals to 1 over 4. So chef, calc. So any guess, no? So the answer is 10. So it will take 10 hours for Tukmol to finish this alone. Okay? Okay, moving on. So an age problem. So John is 4 times as old as Harry. In 6 years, John will be twice as old as Harry. What is the age of Harry now? Okay, so let's imagine the scenario, no? So John is 4 times as old as Harry presently, no? So this is the present times. So after 6 years, what will be the age of John? So John will increase by 6, no? G plus 6. And also Harry, it will be H plus 6. For after 6 years. Ba? So therefore, if there will be a new relationship now, so John will be twice as old as Harry after 6 years, then we can say that after 6 years, John will be twice as old as Harry 6 years from now. Ba? So twice as old as Harry as after 6 years, no? So therefore, we can solve the simultaneous equation, no? This two. So we have J minus 4H is equal to 0. And then we have here, so this will be equal to J, and this will be negative 2H. And then I can transpose this to the other side. So we have 12 minus 6, so this will be 6, no? To solve for the age of Harry. So we can use the equation here to make things faster. Ano? So mode equation 5-1. So we have 1, negative 4, 0. Yung check first pala, ano? Okay. Okay, 1, negative 4, 0. And then 1, negative 2, and 6. So the age of John is 12, the age of Harry is 3. So J is 12, Harry is 3. Therefore, Harry is 3 years old, no? Now, no? So the now. Okay, presently. Okay, so that will be all. Thank you guys for listening.